السلام عليكم، مرحبا، يعطيكم العافية، كيف حالكم؟ Now I'll do this video for showing or for the more explanation about the turning point. Now if I have an XY axis, that's the x-axis, the y-axis, and if we have this curve which is about to be like this. Now we say that we have a turning point. As you can see, the curve is going up, then at a certain point stop somewhere, and then going down. That's a turning point. That's called turning point. Okay, then it's going down up to here somewhere. It will stop for a moment, then it will go up again. Now that's called, we have two turning points in this, for this function fx, for this fx, the function. Okay, that's a turning point. Now, as mathematicians, they have studied the turning point. The turning point, if we draw a tangent to the turning points over here, a tangent, they found out that this tangent is parallel to the x-axis, and the other tangent also is parallel to the x-axis. They want to study the behavior of those tangents. They went to the x-axis. If I have those 2 points, let's say 4 and 0, let's say the coordinates 7 and 0, and they wanted to find the gradient of the x-axis. X-axis is a line which has an equation y equals 0, because the coordinates of the y's are zeros. So the x-axis has equation y equals 0. They want to find the gradient of the x-axis. So let's take 2 points. Let's calculate the gradient of the x-axis. y2 minus y1, that's a 0 minus 0, over 7 minus 4, that's equals 0 over 3, which is equals to 0. So the gradient of the x-axis, keep it in mind, it's always like this. The gradient is equal to 0 for the x-axis. Now, as we know, any two lines parallel, they have the same gradient. So any line passing parallel to the x-axis has a gradient of 0. Let's say this line is y equals, let's say 3. Let's say this line y equals -2, for example, because it's passing through -2, the y, and through y. And as those two lines are parallel to the x-axis, so the gradient for each line of those is equal to 0. Means the gradient for the line y equals 3 is 0. Implies that the gradient of the curve fx, اللي اسمه fx in our example, at this point, let's say x equals, let's say -2, at x equals -2 is 0. The gradient at this point is this of the curve at this point is the same as the gradient of the tangent. So it means that the mathematicians, they want to take the advantage of this, the differentiation dy over dx of the curve at the point x equals -2, which is a turning point. So the differentiation of the curve at x equals -2 is equal to 0. So that's That's the point of this lesson, to show that to find the turning points, to find turning points, turning points for any curve, point or points, let me put it in bracket. It could be 1 point, it could be 2 points, it could be 3 points, it could be no points. Okay, so find the turning points. To find the turning points for any curve, what we used to do, we used to differentiate the curve and put it equal to 0, and we will make an equation and solve it. In this case, we will find the turning points. For example, let me go back to the book. This is your book. Turning points, or listen to this and please listen careful. Turning points or اسمها إلها اسم تاني, stationary point. يعني ممكن في السؤال يقول لك find the turning points. Means differentiate equal to 0, solve it. Or they may say find the stationary points. Means they are pointing to those 2 points, turning points, the maximum and the minimum. And sometimes this we will call it local maximum. Local maximum. That's a local minimum. That's local. What do you mean by local? And what do you mean by extreme maximum? I'll show you. Now, the meaning of if I have this curve, x-axis, y-axis, and if I have a quadratic function just like that, that point called extreme maximum, extremely minimum. This point is called extreme minimum. Minimum means there is no any other point below this point. That's extreme. Whereas if I have this curve, if I have this curve, for example, because the graph comes down. Now that point is not an extreme, it's a local minimum. Why is that? Because the other part of the curve is much lower than this point. So that's local. That's local maximum because the other part of the graph is higher than this. It's not an extreme maximum. That's a local maximum. Okay, this is the meaning of local and local minimum and local maximum. Let's come back to the book. So question says fx is this, find the coordinate of the turning point. So we will differentiate and put the differentiation equal to 0 because we know at turning points the gradient is equal to 0, means the differentiation is equal to 0. Can you hear me please, everyone? To find turning points, we will put the differentiation equals 0. Differentiation equals to 0 because the differentiation represents the gradient of the curve at some point x equals some a. So the differentiation equals 0. Why 0? Because we know that when we have a turning point, the tangent has a gradient 0 because it's parallel to the x-axis. Then it's an equation. We solve it by factorizing. You can solve it by the general formula. And here we have 2 turning points. And to find the coordinates, because they want a coordinates, we need to find the y for each one of those points. So those are the 2 points. Okay. So yes, up to here, أمورنا تمام, finding the turning points. Now, if someone says, Ustaz, we don't have a graph, is it a maximum or minimum? So in our example, as we can see from graph, if we differentiate this, for example, I'll give you an example on that. Fx equals x squared minus 6x plus 8. This is the graph for this. That's a 3. That's, if you do substitution for the 3, that's a negative 1. If you use graphical calculator to sketch this graph, desmos.com will sketch this graph for you. You will find out the minimum is a 3 and negative 1, which is called vertex. Vertex. Okay, now let's find this. Suppose I don't have a graph. Suppose, let's say we don't have a graph. Okay, and let's say find the turning point for this curve for fx. Find the turning point, or they may say find stationary points. Okay, let's find them. Solution. First of all, as we said, we need to differentiate. So f prime x equals 2x minus x, differentiation. And as it is a turning point, from my information, turning point means the gradient at that point is equal to 0. So we put this differentiation equals 0, so we can find the turning points. Means 2x minus x equals 0, means 2x equals 6, means x equals 3. That's the coordinate x-axis for the turning point. Let's substitute this turning point into the function fx or the y. So y equals 3 squared minus 6 times 3 plus 8. That's not 31, that's a... So y equals 9 minus 18, negative 9 plus 8, negative 1. So the turning point is 3, negative 1, as you can see. Suppose I don't have a graph, and I need to find the turning point. Hey, turning point is turning point. Let's say I do not know how to sketch, or the sketch of this function is very complicated. How I can tell without graphing what is the nature of this turning point? Is it local maximum or local minimum? Is it local maximum or local minimum? We don't know. We don't have a graph, let's imagine. So scientists, mathematicians, they have invented another method to find the nature of the turning point. Is it maximum or minimum? They say we have a test. We have a test to distinguish between maximums and minimums for turning point. يعني السؤال in this question, find the turning point only. طلعنا turning point. لكن is it local maximum, local minimum, is it minimum, is it maximum? We don't need to graph. We don't want to graph. We cannot graph, let's say, for example. How I can tell, is it maximum or minimum without graphing? Mathematicians, they have invented a test for that. The test says, find the second differentiation. Means what? Means differentiate again. The function fx is equal to x squared minus 6x plus 8. The differentiation f double prime fx, only x, 1x, fx equals 2x minus 6. Now the second differentiation, and we got the turning point at x equals 3. The second differentiation, we find it. Now, if the second differentiation was greater than 0, so at x equals that a, that number, we have a minimum. If the second differentiation at this point is less than 0, so at x equals a, we have a maximum. So let's do second differentiation. Second differentiation is differentiate again. 1 times 2 is a 2. X power 0 راحت. Negative 6 is a 0, so that's a 2. Is it greater than 0 or less than 0? Of course, as you can see, 2 is greater than 0. So at x equals 3, that 3, which we got from the previous slide, we have minimum. We have minimum. So the test of the second differentiation. The test of the second differentiation. So the second differentiation, when the second differentiation in our example is greater than 0 at x equals 3, we have a minimum. And then we can find out the coordinate, the y coordinate of the 3 by substituting this 3 into the y as we did. So it was a negative 1. So that's called the turning point. Now the nature of this turning point is a minimum. Okay, I'll give another example. If we have y equals 2x cubed minus 2x squared minus 3. That's a cubic, as you can see. That's a cubic. Now, the question says, number 1, find turning points for this curve, for this function. Number 2, find the nature. Find the nature of those turning points. Yani, is it minimum or maximum? Okay, so let's start solving part A. Find the turning points means the differentiation equals 0. Supposed to be, as you know, gradient equals 0. Implies that. Let's differentiate this. So y prime, y prime, let's say, y prime, that's a differentiation. Now 2 times 3 is 6x squared minus 4x. That's the differentiation equals 0. That's a quadratic equation. We need to solve it either by factorizing or the general formula. So we may factorize. That's a 2 common factor. X means 3x minus 2. If you have any problem in factorizing, go back and revise algebra 1. So either 2x is equal to 0 or 3x minus 2 is equal to 0. Implies that divided by 2, x equals 0. Implies that x equals 2 over 3. Now those are the turning points. We need to find the nature now of those turning points. Number 2, finding the nature of the turning points. Is it maximum or minimum? So we'll do second differentiation for the x. And the second differentiation, this was your first differentiation. Second differentiation, differentiate this again. Now, 6x squared, that's a 12x minus 4. Now, that is a second differentiation. Let's do the test. Let's apply the test. Let me write down the test again. If the second differentiation at those two values greater than 0 implies we have a minimum. If the second differentiation at any one of those 2 points is less than 0, so we have a maximum. Now, the second differentiation that we will apply the test on is my second differentiation, 12x minus 4. Tamam. How many points we have? We have 2 points. So let's start with at the first point x equals 0. Let's substitute 0 into the second differentiation. So the second differentiation at the point 0 is equal to 12 times 0 minus 4, which is equal to minus 4, which is less than 0. At إذا implies that at x equals 0, we have a maximum. Now, that is at x equals 0. Let's do at x equals 2 over 3. At x equals 2 over 3, let's apply the second differentiation at 2 over 3. Do substitution. 12 times 2 over 3 minus 4, that's equals to 8 minus 4, that's a 4, which is greater, the 4 is greater than 0. So at implies that at x equals 2 over 3, we have a minimum. Because the test says if the second differentiation greater than 0, we have a minimum. If the second differentiation less than 0, we have a maximum. بالعكس, greater, minimum, less than, maximum. Okay, now we can find the coordinate of those 2 points by substituting those 2 x's into the y to get the y coordinates for each one of them. Now this comes to the end of this video, and as a summary, we found the turning points for any graph, for any function without a graph, without graphs. If we have a graph, it's very easy to find which one is a turning point. And then in this video, we found out how to perform a test. We can perform a test for the function fx to find the nature, for turning points. Turning points. Is it a maximum? Is it a maximum or minimum? Tamam? So let's come back to the book, and I need you to solve questions where you can find in your book. And this comes to the end of this chapter. Next time, inshallah, if you don't have any question, we will start with the next chapter, which is sets, functions, and vectors. That's an easy chapter, and it is very easy if you practice more and more. Thank you very much. Bye-bye.